Okay. Okay, so we learned it's exactly same, so I did not discuss in detail. Next is this, if there are 4 atoms, do you know these things in what is torsion angle in dihedral angle? Everybody knows this? Yeah. So, what is torsion angle? Can somebody explain? Maybe in Japanese is okay. Can somebody explain in Japanese what is torsion angle? What is in Nihongo, what is torsion angle? You know this or no? So, in torsion angle, so in regular angle you will consider 3 atoms, right? That is a regular angle A, B, C. But in torsion angle you consider 4 atoms A, B, C, D. So, you know or not? I am confused. This is somebody knows this one? You probably know, but maybe you do not know in English probably, I think. It is again very simple. Let us see. So, this is the, I will just explain quickly. This is the angle between 2 planes. What are the 2 planes? So, in this case ABC is one plane and BCD another plane. Plane you understand, right? So, my hand, this is a plane. So, this is a line, right? This is line. But plane means something. So, this board, this is the plane of the board. This whole thing is a plane. And in this torsion angle definition, these 3 atoms are in one plane and these 3 atoms in another plane. So, maybe 3 atoms are in this plane, other 3 is this plane. So, it can move. So, this angle between this angle. So, AB maybe C and BCD is like this. So, they are, if they change, that this is the angle between the planes, this is torsion angle. And we need to calculate the energy of that one also, and E torsion. So, we have to find out what is the energy of torsion. So, which means that if your molecules are like this, if it changes, will the energy change? Energy will change, but how? Is it like the same way as before, or you have a new energy expression? So, so we look into this torsion angle. See, you know this molecule, this one. What is this molecule? C2H6, right? Ethane, that is ethane, right? Is ethane. Okay. Okay. I will explain torsion angle. So, I do not have a model, but what can happen, let us say this is the angle we are talking about, torsion angle. So, maybe this hydrogen, it can, there are 4 atoms, right, H, C, C, H, and there is one plane which has this, another plane which has these 3, and they have angle. But you can change this angle if you rotate this bond. So, I do not have model, but it is something like this, CC, right. and you can rotate it. If you rotate, your hydrogens will change. This hydrogen was here, it will just move. You understand this one? Yeah. So, which will change your torsion angle. And if you plot that, let us say where I put the red one. So, torsion angle, let us say phi, and energy, you will actually get something this kind of energy you get. Why is that? Because if you rotate, can you tell me how much you can rotate, like 90 degree, you know this 90 degree, 180 degree. So, if you start to rotate this bond, I want to rotate this one. What is the maximum amount you can rotate? Is the 360 degree, right? Because 360 degree is same as 0, that is the rotation. So, point is okay, let me make this more clear. So, phi I am plotting, phi is 0 here, 360 here, but these two are same, 360 and you know this one, that 360 degree and 0 degree are the same if you start to rotate, right, because this is 90, then 180, 270, 360, it is the same thing. So, energy of this and this have to be same. So, if it starts here, it has to come back here, and very often they are like this. So, they have some sort of periodic or periodicity. You know this term periodicity, which means which repeats. So, it is like a wave something repeats. So, in torsion angle also the energy it will repeats, it is like this. And if it is a periodic function, then one way to represent and this you can represent by cosine or sine, right, because any periodic function you can represent by a trigonometric function, cosine or sine, because sine cosine also repeats the value, and that is why the energy torsion was represented. There is something like this, there is some other terms as well, but mostly is a cosine function. Why the cosine function is taken? The reason is your torsion energy, that is a repetitive, it repeats, and 0, 360 same, so it has to come. And one way to represent, not the only way, you can use some other series as well, but one easy way to represent using cosine or sine, because cosine sine also come back like that. Is it clear? Little bit clear, I think. Okay, we will keep this part. Okay. And these are, so we have learned 3 terms till now, and these are called bonded terms. Bonded means the atoms are bonded to each other. In the bond case, the 2 atoms 1, 2, angle case 1, 2, 3, and torsion case 1, 2, 3, 4, all are bonded. But in a molecule, you have another type of interaction, which is non-bonded. Non-bonded means where the atoms are not bonded to each other, they are far, but still they can interact. And one I think you of course you know, electrostatics, which means that you can think of that your atoms, whatever the atoms here and there, they all have some sort of charge. These are charges.